Alright, ladies and gentlemen, today we are doing 8.8 Simplifying Radicals Day 1. We're going to do more of this tomorrow when I'm actually here, but I wanted to get you guys started on a little basics, and then tomorrow will be a little more rigorous. So the content objective is I will simplify radicals using perfect squares, so we're going to learn what those are. And language objective is I will relate a square root to squaring numbers. So I have one for you guys, and it's square the following numbers. So I have 1 through 15. So I'll do a few of them for you, but I do expect you guys to do the rest. So 1 squared is equal to 1. 2 squared, well, that's going to be equal to 4. Oops. And then we have 3 squared is equal to 9. And then basically you're going to do that for the rest of this list here. Now, these right here, these numbers, the 1, the 4, the 9, the 16 that you're going to get 25, the rest of those numbers, those are known as perfect squares. The reason known as perfect squares is because they're basically a number squared. Now, as I stated before, those are known as perfect squares. We're going to be using some of those, but we're not going to be working a lot with them. And then I have a definition for you guys. So in mathematics, a square root of a number y such that y squared is equal to a. So in other words, basically a number whose square, the result multiplying the number by itself, is a. So for example, let's say my y value was 1, then 1 squared is equal to 1. That makes a 1 as well. Now you can do that with 2. So basically the number you're squaring goes here, the perfect square is over here. So a represents that. And there's also an example here on the slide where you have 4 and negative 4. Those are square roots of 16. So the square root symbol looks something like this. If I take the square root of 16, basically that's 4 times 4. So the square root of 16 would actually be 4. And again, that's going to be because square roots and squaring numbers are opposite things. So for example, if I take 4 and I square that, which I have over here, that's equal to 16. Now if I take the square root of 16, that's doing the opposite. So it's going it's going this direction. That's going to be 4. Now what we're going to do is we're going to create vector trees to be able to find, square roots of numbers. So we're going to talk about lowest vector. Lowest vector is a prime number that goes into the given number. So I want to remind you guys, a prime number is a number that can only be divided by itself and 1. So for example, 2 is a prime number. 3 is a prime number. 4 is not a prime number because 4 is divisible by 2. 5 is a prime number. These numbers can only be divided by themselves and 1. 6, not a prime number. It can be divisible by 3 or 2. 7 is a prime number. And I'm sure you guys can figure out some more on your own. Now what we're going to do here for the number 98 is we're going to create a factor tree using the number. So here's how factor trees work. Now you put lines, and then basically you start listing off factors. Now I like to do this as efficiently as possible, so if the number is even, I divide it by 2. So I can see this divisible by 2. Now I have 98 divisible by 2, that is going to be 49. Now I did this one in my head. You guys might have to use a calculator, you might have to guess and check a little bit. You might have to do it the long way. Go here, divide it in there. And you will eventually get the correct number. Now, 49, not an even number. This right here is a perfect square though. I know that this is 7 times 7. Now in class I'd usually be asking you guys if you have any questions. Unfortunately I'm not in class, so you guys are going to have to work together if you do have questions. And I'm going to go ahead and jump into a couple examples. We're going to be using this to simplify square roots. So my first example is find the square root of 94. So we're going to use a factor tree, just like the previous problem. And again, this is an even number. I'm going to start with 2. Now, so how many times does 2 go into there? Again, you might have to do this the long way. I happen to know that it's 37. Now, what numbers go in 37? I believe that this is prime. Again, prime means that only itself and 1 divided into this, not divisible by 2. I tried 3 already in my head, didn't work. 4 didn't work. Definitely not going to be 5. Not a multiple of 6. This basically is not on your times table that you guys do all the time. It's not appearing there, so this is a prime number. Now, I put this example here because I wanted to show you what to do if you don't have pairs here. If you don't have pairs, you can't do anything with this. This is going to be the square root of 94. This right here shows that I can't do anything else. What I need here is to have pairs. And I'll show you what I mean by that on the next example. Alright, now here I have 45. I'm going to do the same thing. Now 45, I happen to know that 5 goes in there and 9 goes in there. Now 5 is prime, so I'm done with that. This one's not prime. So I'm going to factor that further, and I get 3 times 3. Now, here's what I meant by having pairs. So I have 2 3s here. I have a pair of 3s. So I'm going to circle that, and what's going to happen is I'm going to write the 3 on the outside of the square root, because this is a perfect square. So if I take the square root of this, the answer is just 3. Now this might be difficult to grasp at first, but we're going to have plenty of practice, hopefully today and tomorrow. Give your best shot, guys. Now this 5, there was no pair, so it stays in the square root. So what I have here is I have 3 square root of 5, and this is my answer for this problem. Alright, here is a whiteboard problem if we were in class. I'm going to help you guys a little bit and tell you it's divisible by 2, and also you're going to have 27. Now this 27 can still be broken down quite a bit, so I'm just going to put these right here as a clue. And I'm going to ask you guys to remember, you can only take pairs out. Alright, now what happens if we have a variable? Do the rules still apply? Well, I have power of 6, I have an even power. Next example, I'm not going to have even power. Well, if I break this down to a factor tree, technically I have this going on. And then I can break that down further. And basically, eventually, I'm going to have x times x times x, basically 6 times if I keep breaking this down. Now, the rule I gave you guys before is to take out pairs. So I'm going to take this out, I'm going to take this out, I'm going to take this out. So I have 3 pairs here. So what this is going to look like, I'm going to have x to the power of 3. Because this becomes an x, this becomes an x, and this becomes an x. So I have 3 pairs, so that gives me x to the power of 3. And again, it's kind of similar to the number examples. Now, we're going to do the same thing with this one. Now, I kind of already did this one before because I had x to the power of 6. So I already know that I'm going to have 7 of these. Now, I got a pair here, pair here, pair here, and I got 1 by itself over here. So this right here is an x, this right here is an x, and this right here is an x. Now, these go on the outside because they're pairs. So I'm going to have on the outside, just like my previous answer, x to the power of 3 because I have 3 pairs. Now, I have this one left alone inside. So I'm going to have x to the power of 3 square root x. The one that's by itself, anything that's left, gets left inside. All the pairs, one thing goes outside. And I have one more example here. Now I have numbers and I have variables. I'm going to help you guys a little bit here. So I'm going to have 5 times 5. 5 is prime, so I can stop there. Now I have 9 of these. Now, I'm hoping you guys kind of figured out something. I have an even number here. Basically, I divided that by 2, and that gave my number on the outside. I have an odd number here. I can do the same thing. I can divide this by 2, I get 3, and I get a remainder of 1, so that 1 stays inside. I'm going to do the same thing here. It's kind of like a shortcut. How many times does 2 go into 9? So I just put the 5 for this. Sorry if I confused anybody, but no. It goes into there 4 times. So I'm going to have x to the power 4. And in my square root, I still have one single x left in there. So my answer is going to look like this. Alright, now summary. How do you find the square root of a number? I want you guys to use the following words: factor, square root, and pairs. So I want you guys to use these 3, and as you can see, this is my last slide, so I'm not going to give you my answer. I think we're done with that. We're taking the training wheels off, guys. So I'm still helping you guys out with words. But I do want to add one quick slide real quick. Do another example. Let's go with 24 and then x to the power of 5. Now let me break this down right here. So I have 2 and I have 12. Okay. Now I have 2 again, and this is 6. And then I have 2 one more time, and I have 3. So what's going to happen here is this is a pair right here, and then these 2 get left inside. So I'm going to have 2 on the outside, and then, okay, for my x's, I have x to the power of 5. So I said you can divide by 2. So this divided by 2, I'm going to get 2, and then I have a remainder of 1. So I'm going to have square root, and then I have 2 times 3, which is going to be 6. I'm going to leave that 6 inside. They weren't pairs, so they get left inside. And then I have 1 x left over. Now I really wish that I could have been here for this lesson, but unfortunately I have to be out again. I will be back tomorrow, and again, give it your best shot. On the homework, I'm going to attach the answer key as well, so you guys can check your answers. Just remember to stay tough, don't give up, work together, and you guys will be fine. Good luck, guys, and may the force be with you.